Hi, it's Mrs. Pope, and today we're going to be talking about solving exponential equations. Our goal is to use properties of exponents to solve exponential equations, and we'll also be talking about compound interest. So first, a key concept. If b is greater than 0 and b does not equal 1, then this statement holds true. If b to the x equals b to the y, this only happens if and only if x is equal to y. You may say that makes common sense, but we're just saying if we have the same bases, whatever their exponents are, they must be equal to each other. This sounds basic, but we must use this property to answer most of our questions today. So for instance, if 32 to the power of x is equal to 32 to the power of 9, obviously x is equal to 9. That's a simple one to state the concept. If xyz, doesn't matter what it is to the power of x, and that's equal to xyz to the power of happy face, I don't care what it is, x is going to be equal to happy face. We don't have any happy faces today other than that, but hopefully you get the point. No matter what, if the bases are the same, the exponents must be set equal to each other. Let's look at a few examples. First one is to solve 2 to the power of x is equal to 8 to the power of 3. Hopefully you're saying, well, based on that property, the bases needed to be the same before I can apply the rule that the exponents are the same. That would be correct. So your goal is to make the bases the same so that we can use that property. Well, 2, I can't really change 2, and there's nothing smaller really that I could raise it to a power of, but I could turn 8 into what we would call base 2. This is where knowing your perfect squares and cubes comes in handy, because you should recognize quickly, ooh, 2 to the power of 3 is the same as 8. So I could really say 2 to the x is equal to, not 8, but let's just call it 2 cubed. You agree that 2 cubed is the same as 8. I'm doing what's called turning this into base 2. When you get into your college algebra courses and beyond, you'll start talking about base 2, base 4, base 5. This is a little intro into how we change the bases of numbers. So base 2, now we know power of a power, we should multiply these exponents. So 2 to the x is equal to 2 to the 9th power. And so now I have the same bases. I know that these will be equal to each other. So x will be equal to 9. And double check in your calculator. 2 to the 9th should be the same as 8 cubed. All right, example 2, let's solve 9 to the 2x minus 1 is equal to 6 to the 3 to the 6x power. So, again, we need the same bases. I'm going to make this, hopefully you're seeing that, base 3. So let's make this 3 squared to the 2x minus 1. And now we're going to see we have the same bases. Of course, power to a power, you multiply. Don't forget to distribute. Hopefully you can see that. It says to the power of 2, parentheses 2x minus 1, is equal to 3 to the power of 6x. So we have 3 to the power of 4x minus 4 is equal to 3 to the power of 6x. Now that we have the same basis, set the exponents equal to each other. So 4x minus 4 is equal to 6x. And now let's solve. Negative 2x minus 4 equals 0. Add 4 to both sides. I'm doing this quick because it's algebra 1. Negative 2x is equal to 4. Divided by negative 2, divided by negative 2. X is equal to negative 2. Does that look right? Negative 4x, let's double check my work, minus 6 minus 6. 4 minus 6 is negative 2. Then I added 4 to both sides. So that got rid of that. Divide by negative 2. Is that right? Yep, divide by negative 2. X is equal to negative 2. Any questions there? I see a mistake. I hope you found it. Hopefully you were saying something. Probably not. You probably just followed me all along. Hope you see it. If not, I'll give you 1 second to find it. Okay, you didn't find it. If you did, hopefully you noticed when I distributed this, I called this a 4 and it should have been a 2. Be honest tomorrow. Let me know if you found that or not. So really this should have said 4x, and I know you use pencils, so this will be just easy to erase. 4x minus 2 should have been set equal here. So this should have been a 2, and this should have been a 2, and a 2, and a 2. All the 4s were really 2s. Keep you on your toes. Divide by negative 2, divide by negative 2. Our answer would have actually been negative 1. Hope you enjoyed that mistake. All right, last example for today. Example 3, compound interest. We're going to be using this a lot. You know I love money. So this is the formula. A is equal to P times 1 plus R over N to the NT. Looks like a lot. It's just plug and chug. Not that big of a deal. A is the money in the account after however long you've kept it in there. P is the initial amount, how much you put in to start. R, interest rate is a decimal. N, the number of times compounded. I'll talk about that in a minute. And T is the time in years. Compound interest is what we looked at when we talked about the Dave Ramsey and stuff and investing and seeing how fast your money grows, the Ben and Arthur example. So we're going to see today what would happen if Jade saved $25 per month. And I made this example of something you could actually do. And let's see what would happen. What if for a year you save $25 per month and then invest it in a mutual fund that pays 12.5% interest compounded monthly. Let's talk about what it means, interest compounded monthly. We understand if you put money in a bank, they give you interest. It depends on when they give you that interest is how many times it's compounded. So say you just put your money in a bank, $1,000 pays 10% just for easy numbers. That means you would make $100 off of that. That would be your interest. Well, they may only compound yearly, so they'll wait till the end of the year, then they'll give you your $100. Now you have $1,100 in your account. Or they could compound monthly, which means they'd take that $1,000 they were going to give you, divide it up over 12, and they'd give you some of it each month. So you actually make a little bit more money the more frequently it's compounded. So when you're doing problems, we're going to be doing compounded monthly, which means you would use 12 for number of times compounded. If it says yearly, you'd use 1. If it says daily, 365. So we're going to be using different numbers for how many times it's compounded. So watch out for that in the problem. So if she doesn't touch it until she retires, which will be 65 years old, and let's assume Jade's around 18, how much will she have? So let's see how much you would put in. If you save the $25 for a month for 12 months, you would have $300. So our formula is going to look like this. $300 times 1 plus the rate is a decimal, 0.125, divided by 12, because it's compounded monthly, to the power of 12 times, that'd be 47 years. So just save $300 and leave it alone for 47 years. How much do you think you'll have? Take a guess. All right, when you're calculating this in your calculator, my suggestion would be to simplify these two first. So first I would find out what this is in your calculator. So if you do that, you end up with 1.01. And then 12 times 47 is 564, I think. Yeah, that's what my notes say. So simplify this, and now you can put it directly in the calculator. So 300 times 1.01 to the power of 564. OMG, how much do you think she's going to have? Oh, $82,000. $82,106. Just by saving $25 a month for a year and then throwing it in an account. Now, of course, this is a high interest rate. This is assuming you invest it, and this will be the average stock market of a really good mutual fund or interest rate. So, of course, you're not going to be guaranteed 12.5%. We'll talk about the details later. But this just shows you the idea of compound interest. Now, let me show you what happens if I decided. What if I decided right now, I'm going to do what Jade does. I want to be like Jade when I grow up. So what if Mrs. Pope did the same thing until I retire from now? Well, I don't have quite as much time, so compound interest isn't going to help me as much. So if I do it from now, I'm 34, until I retire at 65, guess how much I'm going to have? Womp, womp, womp. I'm only going to have $1,400, what is it, like $16.63. Boo. I wish I would have started when I was your age. Thanks for watching, and remember, you are responsible for your own learning.